discussion will be the pointers. Okay, so what is a pointer? Let us understand what exactly do you understand by a particular pointer. Okay, pointer, what is pointer? Okay, what is pointer? A pointer are, you can say, pointer are generally used to store the address of a variable. That is, whenever you want to store the address of a particular variable, then you will use a pointer. Okay. Now, what is the syntax for defining a pointer? The syntax for defining a pointer is nothing but what? You have to write what? You have to write a data type. You have to write a data type, and then pointer variable. So this is syntax. Example, write the data type. Int is a primitive data type, and pointer variable you can give anything, but there should be star. So star p is a pointer variable. So this is how you can create a pointer variable. Okay. Now what will happen when you create a pointer variable? I will show you. Okay. So see, for example, if I create just a variable int a. So int a means I have created a particular memory location. I have created a memory location with the name what? With name a. I have created a memory location with name a. Fine. And you can store any value. For example, if I write a equal to 5, it means that I have created what? I have stored 5 in this particular memory location. And this memory location will have a particular address, and that is randomly generated by a particular computer. Okay. So this is how a particular variable is created. Okay. Fine. So this memory location name is a. So this memory location name is a. It is holding a value that is 5, and it have this address. So this is an address. This is an address. This is the value. Okay. And this is the name of a variable. This is variable name, or you can say it's a variable name. Okay. Fine. Now, whenever you want to store, whenever you want to create a memory location, one more memory location. Okay. So you want to create a one more memory location, and in this particular memory location, you are interested in storing the address of some variable. For example, you want to store 2005. So whenever you want to store 2005 in a memory location, then you have to define that memory location as a pointer variable. So we will define that as pointer means int asterisk p. So this is a pointer variable. So pointer variable means what? P is generally used to store. P is generally used to store what? It is used to store. It is used to store a address. It is used to store the address of a variable a. Okay. So here, whenever you are using a pointer, remember, whenever you are using a pointer, there two operators are very much important. That is asterisk and ampersand. The asterisk and ampersand, these two operators are very commonly used with the pointer. So asterisk means value at. It represent, asterisk represent the value at, and this ampersand represent what? This ampersand represent the address of. Okay. So ampersand represent the address of. Okay. So when you are defining a pointer variable like this, whenever you are defining a pointer variable, so you will use two operators, that is asterisk and ampersand. So asterisk represent a value at, and ampersand represent the address of. Okay. Fine. So whenever you want to create a memory location where you want to store the address of some other variable, that is, you want to store the address like this. You want to store the address of some other variable. That is, yeah, I am storing the address of A because I have written what P equal to ampersand of A. So when I write P equal to ampersand of A, it means that I am storing the address of a variable A into this memory location, and that is possible because why? My P is a pointer variable. So this is my P, it's a pointer variable. So I can hold the address of some other variable. So I am holding the address of A. Okay, and this particular pointer variable itself has some address. So let us assume that this is 5000. Okay, so whenever you want to create a variable which will hold the address of another variable, so you will define that particular variable as a pointer variable. Okay, and that ampersand will represent the address of that particular variable. You are storing that address into a P, which is a pointer variable. Okay, so this is what a pointer, this is what a pointer all about. Okay, now let I show you how you can do that in a coding. Okay, so I define a pointer variable asterisk p. So this is my pointer variable, but I also required a variable because pointer variable is used to store the address of some other variable. So what I will do, I will take the value of a through user. I will take the value of a through user. So enter a, that is scanf %d, and this is ampersand of a. So ampersand of a, that is address of a. I have stored the address, the value of a, the value of a, that is %d, the integer value I have stored in this particular address. That is, this means that address of a means what? This is 2005. In 2005, I have stored an integer value, that is 5. So in 2005, I have stored an integer value, that is nothing but a.
सर स्टूडेंट ऐड होना चाहते हैं.
Okay, so what I did, I have created a pointer variable asterisk p. This is a pointer variable. A is a ordinary variable. Okay, and %d is a format specifier representing an integer variable. Okay, so %d is used to store an integer value, and ampersand a means address of a. For this example, my address of a is what? My address of a is 2005. So in 2005, I am storing 5. That is nothing but a. So in 2005, I am storing 5, which is stored in a variable that is a. So value of a will be 5. Okay. Now I have used a pointer variable. And what is the use of a pointer variable? I told you, whenever I want to store the address of another variable. So whenever I want to store the address of another variable, I will define that variable as a pointer variable that I already did. Okay. Now I want to print the value at this pointer variable. So then what I will do, this is p equal to ampersand d. Now here I will write asterisk p. So what is asterisk p represent? The value, asterisk represent the value at p. So value at p means what? P is holding the address of a. So p is holding what? P is holding 2005. So when I write asterisk p means value at 2005. So what is value at 2005? The value at 2005 is 5. So what will be printed? 5 will be printed. Let us see the output of this. Okay, so I'm going to the terminal. So coming here terminal, I will use the compiler to execute that particular code. So this is done. Now I will see the output. So my output is in this particular file. Okay, now entering the value of a. So here 5. So this 5 is stored in 2005. So 2005 address pay, I have stored the value 5. Okay, now I have used p equal to 5 because what p is holding? P is holding the address of a, that is p is holding the value, that is 2005. P is holding 2005, and asterisk means what? Value at that 2005 is what? 5. Understood? This is a concept for pointer. Okay, now I go to the next topic, which is called a structure, which is very much important. Okay, now for structure, you know that how many data types we have. There are two types of data type we have. One is what? Primitive primitive, okay, primitive data type, or you can say predefined data type, predefined data type, okay, or primitive data type, which is also called as built-in data type, or you can say it is also called as built-in data type, built-in data type. Okay, so this is one category. There are how many types of data type? There are two types of data type. Okay, the first is what? The first data type is your predefined data type, primitive data type, or it is called as built-in data type. Okay, the second data type you have is what? It is called as user-defined data type. User-defined data type. Okay, fine. Example of what predefined data type is what? For example, so this is int. So this int is not created by me. Okay, this is not created by me. Okay, this is already created, this is already present. Int, float, double. Okay, so int, float, double, char, these are the data type which is already created. So this all are called as predefined data type, primitive data type, or it is called as built-in data type. Okay, now second is user defined data type. Second is user defined data type. So whenever you want to create a user defined data type. User defined means a data type, that is, you can say a, that is a data type created by the user. Who are the user? I am the user. So whenever I want to create my own data type, so I will use then I will use structure. Then I will use structure. So structure is generally used. So structure. So structure is used to create a user defined data type. So whenever I want to create a data type, it's my own data type. So I will define a structure. Okay, I will define a structure. But I also should understand what is the difference between an array and a structure. Okay. Now, if I say an array, if I talk about an array, you can store more than one element. That is called as finite set of element. But homogeneous data element are stored in an array. Okay, fine. But if you want to store heterogeneous data element, okay, finite, you can say it is used to store more than one homogeneous data element. Okay, or homogeneous data element stored in a contiguous memory location, that is called as an array. Okay, so homogeneous, it should be finite element, homogeneous data element, okay, and contiguous element. So whenever a finite element, homogeneous data element, and element contiguous the element are stored in a contiguous memory location, then you can call this is an array. Okay, how you can define an array? When I write int a, it is a variable. This is a variable and it is used to store only one value. When I write int a of 5, it is used to store a value. How many value? You can store more than one. How many? 5. This is the size of an array and this is the name of an array. So when I write only like this, so what is this? This is a variable. It will store only one value. When I write a of 5, it is used to store more than one value. That is, it can store 5 values. Okay, so this is an array. But if your requirement is something like this, so your requirement is when you want to store a finite set of heterogeneous data element. What if you want to store finite set of heterogeneous data element. What if you want to store a finite set of heterogeneous data element, then it is not possible with array. Okay, it is not possible with a variable. Okay, then you require a structure. You require a structure. Okay, so I think you understood where when you will use a structure, you use the structure whenever you want to store. Okay, whenever you want to store what, a heterogeneous data element. Okay, so you will create what, a structure. You will create a structure. Fine. Okay, now we will see the syntax for a structure. Syntax for a structure is something like this. Okay, so here you have to write what, struct keyword. The struct is the keyword, then structure name, or you can say tag name. So tag name is the name of a structure or structure name. Okay, you can say this, then a opening, and then this is close, and every structure will be ended with semicolon. That is compulsory. Okay, don't forget semicolon. Okay, so now here you have to write data type. This can be one data type. Data type, this is type 1. Okay, and this is another data type. Okay, this is another data type. This is type 2. Okay, and this is another data type. So you can have more than one, so more than one type element. Okay, so that is why I told you, whenever you want to store a finite set of heterogeneous data element, so these are used to store a heterogeneous data element. This will store, for example, this is used to store an integer. Okay, let us example, this is stored to character. It is used to store a character, and let us assume that this is stored to use a float value. Okay, so whenever you want to store a different data type in one name, okay, whenever you want to store a different data types with one name, so you will use what, structure. So structure will have a more than one element with different data type. You can say the structure will have more than one data element of different 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 type different types. So then you will use a structure. So this is complete a data type. Okay, you cannot say, usually you will find out that data type is of one word. Example, you know that int is a data type. Okay, float is a data type, double is a data type. Okay, ये सब data type है, but ये data type एक ही word के, but जब आप user defined data type बनाते हो, these are data type. Okay, whenever you are creating a user defined data type, this complete is a data type. This complete is a data type. Okay, so this complete is a data type. So this is your complete data type. Okay, so it will be clear whenever you will see the example. Okay, now see, simply one more thing you should remember. If I write only int, it is not at all useful. Okay, if I write only int, it is not at all useful. If I write only double, it is not at all useful. I have to write what, variable. Okay, I have to use what, variable. So what a variable denote, variable is nothing but what, it's a memory location with a name, and it will use to store what, double value. It is used to store a double value. So whenever you are using a data type, so data type, along with this data type, you have to give a variable name. So this is my data type. If I define my user defined data type, so this data type, I should also, this data type is useless. It is useless. Okay, so until I should create a variable. So every structure should have a structure variable also. For example, every data type will have a variable. So this data type is useful when you have a variable. Similarly, this structure is useful only when this structure should have a structure variable. So how you can define a structure variable? The syntax for structure variable is what? Structure variable. structure variable. So what is the syntax for structure variable? The syntax for structure variable is so you have to write this complete structured tag name. This is structured tag name, and then followed by variable, so this structure variable, and then only you can access these elements, you can access this structure elements. Okay, fine. So for accessing a structure element, you should have a structure variable, number one, and number two, you should have an accessing operator, that is accessing operator, which is a dot. Dot is an accessing operator. Okay, so this accessing operator dot is generally used to access this element, or you want to store a value in this particular element, so you have to use this structure variable. Along with structure variable, you have to use this accessing operator, that is dot operator is used, and you have to use this data element. Okay, and then only you can assign a value to a structure element. Okay, this will be clear when we see an example. Okay, now let us see an example. Fine. Okay, now I want to create a particular structure. So for example, if I create a structure, I have to follow the syntax. The syntax is that you have to use a struct, then followed by tag name, then data type. So what I will do, I will use struct followed by structure name. Structure name, I write emp. Okay, then followed by you look at the syntax, then I have to create this. These are the elements. This is element 1, element 2, element 3. So first element, so I will write what? Integer. So integer, employee number, then character, name, employee name. Let us assume that every employee name is of 10 character. Okay, and finally I will write what? Float, that is, you can say, employee salary. Okay, and I told you have to remember every structure should end it with semicolon. Okay, so this is my data type. This is my user defined data type. So I have created what? A user defined data type. So this is my complete data type. So this data type is of 2 words. Okay, so user defined data type is of more than 1 words. This is of 2 words. So this is my data type. Okay, now I told you this data type is useless until you create a variable. Okay, so I have to create what? Structure variable. So how I will create a structure variable? So I have to write the data type. This is my data type. जैसे लिखता हूँ ना मैं, कैसे लिखता हूँ? Int लिखता हूँ. So this is my data type. वैसे अगर if I want to use this user defined data type, I have to write what? Struct emp. Now after that I have to use what? A variable. So my variable is, say, e. Let us assume that e. So e is my variable. Okay, now I can directly assign this value to this structure element, or I can assign it through a user also. So I can directly assign. Let us see how I can directly assign. So this is one way how I can assign. I have to follow this sequence. First is employee number. So here I will write an employee number 101. Okay, then employee name. Let us assume that this is string. Every string is enclosed in a double quote. And third one is what? Salary. Salary is, let us assume that this is 10,000. Okay, this is close. Okay, fine. So this is a structure variable I have created. The structure variable is e, and I have assigned this value. It means that, so this first value is assigned to eno. Okay, and this John is assigned to e name, and this 10,000 is assigned to e salary. So let me print that. Okay, let me print that. So e name, okay, e name equal to %d format specified, because this is an integer. Okay, so this is %d, comma. Now I want to print the value. So I have told you how you will access this value. For accessing a value, you have to follow what? Accessing a value, you have to follow this dot operator. How you will use it? You have to write the variable name dot, and data type, and this is type 1 element name. This is type 1. This is element name. You will write what? Variable, structure variable. You will write the structure variable name, then dot operator followed by element name. Okay, so this is the syntax. Okay, this is the syntax. Okay, so for this case, what is my structure variable name? My structure variable name is E. Second, what is the syntax is that followed by dot operator and then element name, followed by dot operator and then element name. So my element name is ENO. Okay, so this is the first element which I have access. Okay, so this dot operator can be used to access a structure element, as well as this dot operator is also used for assigning a structure element. Okay, so currently I have directly assigned, so I am just accessing a structure element. Okay, so this is employee name. Okay, e name. So e name is percent s. Okay, so here I will use e name. Okay, and third one is e salary, employee salary. So instead of that, I will write employee name, employee salary. Employee salary is what it is. ESAL. ESAL. Okay, so this is employee, the employee name, and this is employee. This is employee ID, employee number. So employee number. Employee number. Okay, so this is done. Okay, so I have saved this. Now I will execute. This. Okay, now again I will go over here. I will compile, showing an error. Why it is an error? Because it is a %d, and I know you know that. So this is a float. For a float, it should not be, the format specified should not be %d. It should be %f. Okay, clear? Now again done. No problem. Now this has been printed. Okay, so this is printed in a single line because I have not used an escape sequence. Now what I will do, I will use the escape sequence /n. After printing this, go to the new line, and again then go to the new line. So I have used this escape sequence. Now output, you will see it will come into a single line. Okay, so this is how I can create a structure. Okay, but you may ask one question, this is, you have directly taken this value, it's okay, but what will happen if I want to take it from the user? If I want to take this value from the user, is it possible to do that in structure? Yes, it is possible to do that in structure, but the way of doing it is little different. Okay, now how you will do that, I will show you. Now you have to create a structure variable. Okay, once you created a structure variable, now you have to enter each and every element. So you have to write what? Enter employee number. So this will be printed as it is. Okay, now you have to take the scanf. Okay, now scanf, and then scanf. Now you will do what? %d. Okay, and e dot e number. Okay, now this is done. Now second one, same way, you have to take what? You have to take employee name. For employee name, you know that %s. Okay, and this should be ampersand. Okay, and this should be, yes, employee email. Okay, employee e name, And now I have to take in some variable, okay, because it is not possible. So what I will do, I will create a name of 10 character. So I will take I will take that in I will take that in a name. I will take that in a name, and then I will copy strcpy. There is a command. This is strcpy is a copy command, copy function. Okay, it's a copy function is used to copy. Where you have to copy a dot e name. Here you have to copy. What you have to copy? Name. Whatever name you have taken, you have to copy that because it is not possible to take it directly because this is a string. So this is string, it contains a set of character. So as it contains a set of character, the set of character cannot be directly taken into a variable. Okay. So in that case, you what you will do, you will create a set of characters, a variable with name. We will take a value in that particular variable, and then you will copy that into a structure element. Okay. And lastly, employee salary. Employee salary, and there is no problem with this. You can directly take %f and sal, sal, sal. Okay, so now this I have taken from the user, and it should be ampersand. Should be ampersand. Okay, and you can directly print it out. Okay, no issue. So this is how you can take a structure value to a user. Okay. Again, okay, so it required a header file. Okay, so you have to include a C string. There is a header file because this definition, this strcpy, so this definition is not present over here. stdio.h does not contain the definition of strcpy. Okay, fine. So it is present here. Okay, so this is done. This is done, and then clear. Done. Okay. Okay. Enter the employee number 12, employee name John, and salary say 15,000. Okay, done. Did you see that? How you can take? I have shown you both the method. I have shown you both the method how you can assign the value directly to a structure element, and the second way how you can take the value from the user and then you assign to a structure variable. Okay, structure element. Okay, is it clear? So, but now one thing you should remember. Now, what is the memory size of this? That is also you have to clear it out. Okay, now what will be the memory size? For example, see, whenever I define this integer variable, so what is the memory size for this? What is the memory size for this? Memory size is it depend upon the compiler. Okay, and if it is a 32-bit compiler, the integer value, if it is a 32-bit compiler, the integer value will take a 2 byte. It will take a 2 byte. Okay, and if it is of 64, if it is of 64, if it is 64 bit of compiler, okay, it will take integer value will take 4. Okay, it will take 4. This will take 2 byte. It will take 2 byte. Okay, and this will take 4 byte. Okay, so let us assume that we have taken a 32-bit. So it is a 32-bit. So what is the size of this? The size of this will be obviously the size of this, because it's an integer, the size of this will be 2 byte. The size of this will be 2 byte. So what will happen if you are using a structure variable? So if you are using a structure variable, so what will be the size of that? Okay, what is the size of that? Okay, now for example, in the structure variable, I have created a structure. Okay, structure of this, how many element? 3 element: ENO, ENAME, ESalary. So my structure will contain 3 elements, but just by defining this, my memory will not be allocated. Okay. मैं जैसे यहाँ पे अगर सिंपली इंट लिखूंगा तो मैं यहाँ पे जैसे इधर में ओनली इंट लिखने से मेमोरी विल नॉट बी allocated. Memory will be allocated when I write int a. When I write int a, then only the memory will be allocated. Okay. So if I write only this structure name, my memory will not be allocated. So my memory will be allocated when I use a structure variable. So as soon as my memory will be allocated, as soon as I create a structure variable. Okay, as soon as I create a structure variable, then my memory will be allocated. Okay, तो यहाँ पे आपका memory allocation कैसे होगा? That depend upon the structure element. तो इसके लिए मैं अगर 32 बिट अगर लिया तो इसके लिए कितना रहेगा? It will be of 2 बाइट और आपको पता है क्या character will take 1 byte and how many character? 10. So it will take 10 byte. It will take 10 byte, and this is float. Float will take 4 byte. This will take 4 byte. This will take 4 byte. Okay. So how the memory will be allocated? The memory will be allocated like this. Okay. For this, and for this. Okay. Now this is for what? This is e number. This is for e number. It will have some address. Okay, so this is for e number, this is e name, and this is e sal. And what is this? This is what? Your structure. Struct. And what is my name is emp. So this is my data type. So this data type will contain this many memory allocation. This memory allocation. Okay, and this is of what I've shown you. This is of 2 byte. This is of 2 byte. Okay, let us assume that if my memory is location is starting from 2000. If it is starting from 2000, so it will take 2 byte for this. So if it is taking a 2 byte for this, so this memory location will start from 2002, and it is taking a 10 byte, so it will go up to 2012. So this is 202 to 2012. This is of how many byte? 10 byte. This is of 10 byte, and this is taking 4 byte. So 4 byte means what? 4 byte. 4 byte means this is 2014. 2014. So this is how the memory will be allocated. Okay, and the value which I have stored is what? This is something, the value which I have taken something 101. Okay, and this is John, and this is say 15,000. Okay, and as soon as I created a variable, that is e. So this is my variable. This is my variable. Okay, and this variable will contain, as soon as I create a variable, this will contain the address of this one, that is 2000. So this will contain the address of this. Okay, and this will always point to this will always point to this is always point to the base address. Okay, so my base address is wait a minute, I will show you. This is always pointing to this. Okay, okay, so this is my pointer structure variable. So this is my structure, and this structure variable is pointing to this. So what is it? This is my base address. So this is pointing to base address. Okay, so my structure variable always point to base address. This is always point to base address. Okay, so that is why this is called as internal storage. This is an internal storage class. So you can say it is an internal storage class. Okay, so it is internal storage variable. Okay, it is internally stored. You can say structure variable will internally store this base address. Okay, so it is got internal storage class which is used to store the base address of a structure element. So this is a base address, so this will always hold the address of the base address. So that is why the structure variable, that is E, it contain 2000. It contain 2000. Okay, is it clear? Is it clear now? If I want to for example, if I want to do one thing, okay, what I will do, um, oh, if I want to see the size of this, if I want to see the size of this over here, okay, now for that there is one function which is called as printf, and there %d, and there is a size of operator, and I have to write to any one of these. Okay, so when I want to size of this, either I can write this one, this uh, structure variable name, or I can use this structure variable name or structure name. So either I can use a structure name or I can use a structure variable name. In both the cases, you will get the size of this, size of the structure. So I'm using this. Okay, I run it. Okay, it required a format specifier. This is LD. Let me see. This is LD. Done. Okay. Take 101. My John. Now see, this is 20. This is 20. Let us check. It will take 20. Whether it will take 20 or not. Okay, so this is how 2 byte. Okay, and this is 10 byte, and this is 4 byte. Okay, and this is 14 plus 2, 16. Okay, now why it has showing you 20? Why it is showing you 20? Because the compiler is of 64 bit. So as the compiler is of 64 bit, so what it will do, it will take what, this is 10 byte, this is 4 byte, 14, and this is float. So this might have, they have taken 6 byte, I think. So that is why it is showing you 20. It is showing you 20. Okay, because it varies. It varies. Okay, it depends upon the compiler, which type of compiler. 32-bit compiler is 64-bit compiler, which bit of compiler you are using, and that why this size will also varies. Because I told you the size for an integer, if it is of 32-bit, it is of 2 byte. But the same thing if it is of uh, if it is of uh, if it is of 64-bit, then it will of 4 byte. Okay, now if suppose if I change this, to double, if I change this to double, okay, so for a double it's okay. If I change this to double, then what will happen? This should be percent. Okay, see, 24. This is changed. Okay, so again it is changed. So it changed depending upon the data. Every data type will have, say, so which have its own size. The size is different. So it depend upon the compiler which you have installed. You will, if you run it in a Turbo C, you will get something else. Okay, if you run that in Borland C, you will get something else. Okay, it depend upon the compiler which you have there. Accordingly, the size will change. Okay, now suppose if I want to copy this, okay, now I want to copy this complete structure into some other variable. Okay, now see, this is my variable E. Okay, now I want to copy this into some other structure, say S. Okay, so this E contain all this, and if I want to copy that into S, so what I will do, I have taken this value, okay, After doing that, what I will do, I will just simply write, I will write some ES. I will write ES. ES is new structure variable. Okay, so I will write ES will assign an S. E will be assigned to ES. So both are structure variable. So E structure variable will be assigned to ES. So E and ES both should belonging to same data type. So as E and ES are belonging to the same data type, you can copy this structure into this. That is possible because their both structure will be same, because both structure will contain these three elements. So it is possible, but you cannot copy one structure element into some other structure element. Okay, you can copy that within that same structure, or one structure variable can copy into another structure variable, provided both structures should belong into the same structure name. Okay, it is possible. So instead of E, I will use ES. Instead of E, I will use ES, and let me check it out whether I'm getting this output or not. So whether my output is correct or not. Done, no problem, no issue. Okay, see, this is one, this is John, and okay, no problem. So this is how, this is an example of how you can copy one structure into another structure. Okay, so you're copying one structure into another structure by just copying one structure variable into another structure variable. You can copy that. Okay, I hope you understood. Okay, I hope you understood this. So I'm closing this. Is it fine? Is it clear, all of you?